conversation to be had about both what happened, what do we do about it going forward, and how do we design the resiliency into all of those platforms you just mentioned and many more, so that the effects of something like this in the future are less catastrophic, or the recovery time is quicker. I mean, that's really at the core, is how do we get better at this?
Well, because you kind of alluded to something right there. It's going to happen again. Maybe not
Absolutely.
this exact thing, but...
Welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology.
This is Darren Pulsipher, Chief Solution Architect, author, and most importantly, your host.
On today's episode, the CrowdStrike event, Building Resilience for the Future, with returning guest Steve Warren, C2 of Intel Federal.
Steve, welcome to the show.
Thanks for having me again, Darren.
With this number 12, I counted 12 times on the show. And hey, I called you on Friday after all this fiasco happened and said, Steve, we need to talk about this. This is so important. And it's amazing. The largest IT outage in history. 1 in 8 laptops were affected worldwide. But the impact that it had was devastating, right? It brought down hospitals, banks, airlines, and the list goes on. And we're still trying to dig out from it. So I said, Steve, we got to talk to Steve about this. So thank you for coming on. It's such short notice. I appreciate it.
No worries. And it's an interesting conversation to be had about both what happened, what do we do about it going forward, and how do we design the resiliency into all of those platforms you just mentioned and many more, so that the effects of something like this in the future are less catastrophic, or the recovery time is quicker. I mean, that's really at the core, is how do we get better at this?
Well, because you kind of alluded to something right there. It's going to happen again. Maybe not this exact thing, but I mean, cyber attacks, and everyone talks about, hey, a cyber war, things like this. We have to be more resilient in our systems, not just in one individual thing. So this will be an interesting conversation today, I hope.
Absolutely. And you hit on a key point there. This wasn't a cyber attack, but I think having it be a configuration / bug in a critical piece of software as the first shot across the bow, at least means that when we recover, we can plan for when it is a cyber attack that will not be something that's easily patched by the vendor itself. And so looking at how do we learn from this experience, both technically and organizationally, at least this one wasn't as malicious as it could have been.
Correct. It could have been far worse, which that's kind of scary.
Absolutely.
All right, so let's talk about what happened, right? I talked about it on my previous episode, but from your perspective, what happened?
Well, I mean, it's the analysis has been done, and we've shown is that an update to one of their key components of the CrowdStrike product had a bug, and it was in the particular system that looks both hooks deep in the system, but also talks out to the web. In order to be able to validate certain pipes in the Windows operating system. There was a DNS foul up, and that itself wasn't the issue. The issue is that then caused the logic error, which brought the systems to a screaming halt. You got the blue screen of death, and so it was
this was not a code update. This was not a software code update.
Not
kind of, sort of.
Yeah. It was a supporting file update,
a configuration file. For no better word, right?
But a critical one. And so the question, and this is really comes down to the complexity of our software. Is that a code update, or is it a configuration fault? At the end of the day,
it doesn't matter.
Exactly. Because that configuration file was consumed by code that was not able to handle the error and therefore caused a crash. So whether it was a bug in the file, which it was, or was the bug in the code that consumed it that wasn't resilient enough to be able to handle an error?
The answer is yes.
The answer is yes. And so I don't think that the splitting hairs on is it a code bug or a configuration file really matters. The effect is identical. systems crashed, and they crashed catastrophically.
Well, it might matter if I look at the DevOps pipeline, the DevSecOps pipeline, because there's this argument, constant argument and conflict, right? Because I grew up before DevSecOps was DevSecOps. That's what I did, right. And it was resilient, repeatability, resiliency. Nothing went production unless it went through the DevOps pipeline. But in conflict with that, we've got a continuous deployment, especially of configuration files, right? Hey, we found this new virus. We need to update a configuration file to handle it. Do I have time to go through a full-blown DevSecOps pipeline, or do I just push that puppy out because, hey, because the threat is higher than the risk?
Yeah. Well, and that's a determination. But I think you hit an interesting point. And this is something I've said for many years, is that vulnerabilities and attacks often happens at the seams. And in this example, the bug, if you will, happened in the seams. It was the bringing in of that file by the code that then caused a logic error. So there was a misconfiguration in the update file that was, sort of the list of things to be looking for. There was code that consumed it that ended up with a logic error. And like you said, in a standard DevSecOps, the code went through its original process and was found to be bug-free. The update file was, correct enough to be loaded, but the testing hadn't happened on that code with that update
with that
file.
Combination, yeah.
And that's something that is hard to test every permutation, like you said. But one of the things that this highlights is in that DevOps process of validating our code, we always take the approach, well, did it work? And this is really a key example of where we need the anti-testing. Not did it work, but what happens when it doesn't? So when we do that DevSecOps environment for the core code, one of the kinds of tests when we have the time to do all the tests, like you were saying, is we should be testing it for its resiliency and for what does it do when it gets buggy code, when it gets a malformed update or a misconfiguration. And I'm not saying it's got to work, but it has to at least fail carefully. And that's one of the things that we're looking at your design criteria. And the quality and assurance testing that you do on that internally when you're building products is building for the negative, not just building did it feature work, but what happens when something goes wrong that you're not dependent on, outside your code. When you're in this case, that piece of code, its job is to consume update files that have been loaded.
Well, yeah, so this flies to me in the face of something that I think the industry as a whole is suffering with, good systems architecture. Because a good systems architecture and methodology would not have allowed stuff like this to happen, both on the Microsoft side and also on the CrowdStrike side. So I think in general, if I look at the industry as a whole, we had major outages at AWS, Azure's had major issues. And when you look at the core fundamental, systems architecture best practices were not used. Yeah. They were just put aside. So I think I would love to see the industry as a whole start to adopt what we already know. We learned it 30 years ago. We've gone away from it. We've abandoned it for speed and agility. But you can have speed and agility, but you still need the core fundamentals there. That's my soapbox. That's my soapbox.
Well, and Darren, I put another soapbox out there, and this is something that's been adopted in a lot of the cloud environments for a number of years, is we know that things are going to get updated faster than we can test them. That's just a given. But if we build one of those core tenets into our requirements of resiliency and recovery, and we build that in, the way you mechanize that and operationalize that is you do continuous testing of that environment. Not does the function still work, but you continuously test it for the aberrant cases, the anomalies. And this is where
what if it doesn't work? What happens? Right.
And this is why, and that it started out with a tool and a set of practices called Chaos Monkey, and then became a larger set of tools chain around something called the Simian Army, which is basically this idea of adding chaos into the system, letting it reign free, and building your system to be resilient against chaotic events. And so Netflix gets the credit of having started this insane way of looking at things, which is they built the original tool. And now many cloud providers are hosting it, and you can actually use it as a service when you're building your cloud. But it could be applied everywhere. It's built on the cloud because of the scaling need, but you could apply the same idea to endpoint systems or anything else, which is even after you've done your development and your production and you release it, having a set of tools attack the system, not as an adversary per se, but as a set of chaotic events, turning off services, misconfiguring files, shutting down ports and services, admin things, just going off and randomly doing things and monitoring how the systems recover or don't, and building to be able to recover from those events. And that kind of continuous testing from an anti-tester or an anti-QA perspective is really how you can more naturally build in resiliency without having to think of every possible scenario at the front. And so that's one way that I think a lot of organizations, both vendors and deployers of technology, can look at, while I'm waiting for the rest of the industry to catch up and build better resilient platforms, I can start to identify the key areas in my operations, in my enterprise, or in my product that aren't recoverable as resilient as I would like them by testing them. And then building in whether it be the recovery and disaster mitigation processes, or in the case of a vendor, building in better resiliency into their code to handle those kind of faults that you can't always think of everyone in advance. And that's, I think, an approach in parallel with doing a better system architecture on the design, but just realizing that the products are already out there. The time to market is constantly going to be your enemy. And so having this sort of running in parallel to identify the key areas to focus on and to continually update the products and the infrastructure to handle what would be another chaotic event. Because the next event won't be that, an update file will be some other thing that was that caused an error in some critical component, some critical boot flow that shuts down system, and we'll have a complete repeat of what we've seen today. And by the way, this isn't the first time this has happened. Everyone's focused on the CrowdStrike event, and it is bigger to people because there's more things relying on technology than there were 10 years ago. But we had this exact problem 10 years ago with an update file from another security vendor that brought all the systems crashing to a halt.
Yes, we did.
Yes, we did. So we've seen this before. It's the same movie, different
same movie, different casts, right? It's like Twisters 2, different, same movie, different cast. A lot better looking people, I guess, because it's doing well. That's what they are saying in the news. So here's a comment I want to make on that. It's not just the products and technology, it's your processes, right? People that had good, strong business continuity processes got through this pretty well. Ones that didn't fare nearly as well. So we've got to define systems, meaning processes, everything, right? And if your disaster recovery and business continuity isn't in a paper book somewhere and on that laptop that you could not boot, it was worthless. So this goes into that whole business continuity, resiliency of your organization, not just one piece of software, not just one system. So that's something that I think we need to get back to. We've kind of abandoned it. And frankly, I think we're going to hit it again, especially when we become more reliant on generative AI, whose attack vectors, which we've talked about just recently, are even more exposed than traditional applications that are out there.
Yeah, and I think going to that point around disaster recovery, business continuity, a lot of people think about it, well, I've got my process, maybe hopefully it's saved more than just on someone's hard drive, but it's a paper document.
Yeah.
And there are two things missing from that. One is the technology and practices that are built into the systems to execute that process once something goes wrong, and the automation necessary to make it happen without waiting for humans to figure out, oh my gosh, we're crashing, now what do I do? Oh, I can't get to my laptop. There needs to be automated processes that when systems start going down, that automatically either isolate, do a complete rollback and update. All those kind of technologies can be deployed in automated fashion. Also, lights out update. There are technologies that have been available for many years at the edge and in the data center to be able to recover a system that has crashed, that is blue screened to death.
let's talk about those.
Sure.
Let's go deeper into those because I know these are Intel products. So
some of them, yeah.
So let's talk about, especially with this, because this was like kernel stuff, right? So before my machine, in fact, it happened to me when I was editing a PowerPoint presentation. I got the blue screen of death. It just boom, and I went, darn it, this really stinks, right? Luckily, everything was saved up in the cloud, and I was okay. But what types of technologies can I use to roll back when something like this happens? We have stuff at Intel, and so there's your softball, Steve.
Yeah, there it is. So let's start with the one for your edge endpoints.
Okay.
There's a technology. It's actually been around since like 2010, 2011, called AMT, Active Management Technology. And at its core, what it is, it's a small little runtime that is built into the hardware that can be accessed over the network securely to be able to do both updates and recovery of systems that have crashed or that you need to be able to update, at evening. So one of the reasons it was originally developed was, let's say you've got a massive, 400,000 laptops out there. You don't want to wait for everyone to come in the morning and have to do the updates of, Microsoft patches or product vendor patches when they're actually trying to do work. So do it when their systems are, in sleep or offline, and be able to talk to them over the network and push the patch before they show up in the morning. That was the original concept of being able to do sort of out of band management of the system. You want to update configuration.
You're telling me that my laptop is connected to the network
always
without me knowing that I'm connected to the network?
Well, you're connected. You're plugged in physically, or you have a Wi-Fi connection. You're connected. But I want to be clear. This is on the enterprise side. So I'm not talking about the home user. There may be
that's good. That's good to know. Yeah.
But in an enterprise where the IT is managing a fleet of laptops and desktops and other edge computing devices, you are connected. And if you're using this technology, that means IT can manage those, can push updates, can do it when you're offline, so it doesn't get in the way of you doing business. Or in the event of an error like this that's already been deployed, they can go and either roll it back, or in the case of this particular one, they can go and delete the file that was causing the issue without having to boot the OS, or if the case of a crash system, be able to do it with the OS crashed and go in, change the file, reboot the system, and get back to a working state.
So this is before the OS is even loaded.
Yeah.
I can run this. So this is way down deep in
the hardware.
In the hardware. This is good stuff because now I can manage. I can manage. But doesn't this also open up a potential threat?
So every technology has potential threats. One of the ways that Intel has developed AMT is a couple of things. Number one, it is a secure connection, so it's as secure as the network itself, using the authentication, encryption, and a validation of the firmware before allowing for any connection. So when that management console goes in to talk to the runtime, the AMT engine, not only is the communication itself protected, the admin function has to authenticate, and the AMT system itself is validating that its firmware is correct before allowing any updates, communications, or any other activities.
So you're checking a hat. You're making sure the AMT has not been corrupted or
through a signature. But furthermore, it's something that IT has provisioned. And so basically IT provisions this on their network, uses their key infrastructure so that they're secure to the level of authentication that they want to use. And they're locking it down to the admins that have that ability. So it allows IT to deploy this into their environment. And many large scale regulated and critical businesses and government agencies are using this feature to manage their fleets, both from a ease of update as well as recovery mechanism. And we found that those organizations that had deployed AMT were able to do the fix very quickly. And so that was one area that we saw benefit for the laptop users.
Okay, great.
And the thing is that this could happen both, when like you found out you crashed, you said, hey, I've crashed, and they can figure that out and push the update to your system, as well as, let's say folks, I think it was Australia was the first place to see it, just from a timing perspective. And so people in other time zones could push that fix before your users even came in the morning to find out that their system had been affected. They could already fix it before they got online.
So for those people, No harm, no foul.
Well, I mean, it still was work for the IT and a lot of lost hair trying to figure out, make sure that was the problem.
That's one way to put it.
But yes, they were able to get operational much quicker. Now, on the cloud side, because there were also many cloud services that were affected as well.
Oh, I did not know that. I thought it was only the laptops.
But... No, there were some dependencies and some things in the cloud, like virtual instances that were affected, not as badly, but it took out a lot of cloud services. Some of it from the DNS mess ups that were going on there. Similarly, there were tools that you could do to basically put in a gold disk version of that and swap back out. So those that had not just had a policy for recovery and resiliency, but had implemented the technologies and the processes were able to recover. And those that didn't, that found out, hey, I have that technology, I can use it this way, have been able to recover, again, not as fast as those that are already operational.
Well, because they weren't used to using it. They didn't have the processes already established.
But a lot of organizations I've heard from have, over the course of the weekend, basically said, oh, I can use that to do this too. I'm going to do that as well. They maybe were doing it for certain patches, and no one had thought about doing a file deletion, which is really the quick fix. But the tools are all there. The ones that are the next phase is the ones that hadn't provisioned. And so figuring out how do I provision these tools to a system that hasn't been, once it's already crashed, it takes a little bit more hand-holding for IT, but they're also investigating right now how to do that to recover the already crashed systems. And in some cases, what is happening is that you bring your laptop into IT and they're doing some things to get you back with some tools that you can get physical access, or there's some other tricks you can do working with somebody online. Basically boot to a USB stick or something like that and be able to make the changes and then recover the system from safe mode. There are techniques, but again, it's more manual. And that's why these kind of foundational technologies, when used in coordination with, like you said, a policy and a procedure for handling these kind of events, are how you recover in a more quick time. Now, would that have prevented every airline flight from not being canceled? Probably not, but it would have meant that it would have been a much quicker time to back in operational for a lot of these organizations.
Yeah, one comment that was made by Matthew in the previous episode was, why are we having Windows boxes running kiosks? Right? Because
they do.
Because they do, right? But his point, it was a very valid point to me, in that sometimes we use the technology we're used to instead of going to the minimal product that is needed to do a job. We do this general purpose, right? Because in the past, the kiosks would have still been up and running because we had a very lightweight something running, but we went to something more general compute.
So Darren, I'm going to play a little devil's advocate on that one.
Yeah.
That I think that's a little utopian thinking there. And here's why.
Of course it is. Of course.
Number one, that kiosk is running an application that I need to be able to hire developers from the commercial workforce to build to. If it's a custom RTOS, I need specialized developers. Even if I said, oh, it's a Linux platform, great. Well, how many of my tools run on Linux? How many of my developers?
Linux,
or apps that I can deploy across multiple use cases. You want the same user interface for the kiosk as you do for the agent that's running a laptop. There's a lot of reasons why you want to have common architecture.
I totally agree.
And here's the thing. Let's say there was a minimized Linux that run every kiosk out there. This could happen to that too.
Yes, it could.
The key here is ubiquity. You have a ubiquitous solution. Some error will occur that will have catastrophic effects because everyone's using it. Today we pick on Windows because everyone's running Windows.
Right, of course.
If that utopian vision was true and everyone was running a Linux and they had all the tools they had running, a patch update would cause the same effect. And that's the thing we have to remember. It's not that, my Windows operating system's worse or better than Linux. It's these systems weren't designed for the resiliency. It doesn't matter whose product you're using.
Right.
We would be in the same bucket. And if we flip the other, say, well, every kiosk should have its own special RTOS, they'd never be scalable because it'd be too costly to manage.
It would be too costly, yeah, and that's the argument I gave him as well. But this goes back to something very interesting. As we become more reliant on technology, and we want commonality, because commonality drives costs down. We know that, right? I mean, I was a CIO. I wanted everything the same. I didn't want variability at all. And then, someone comes in and says, they want a Mac on the network. And I go, get that piece of crap out of here. I want everything the same because it's easier for me to manage, right? That's just how it works. But the corollary to it is I'm putting way too much power on an application that doesn't need that much power. And if it is critical infrastructure, do I want it common? It's easier to attack. There's all of these trade-offs that have to be made. And it's a tough position to be in. If we go and look at Southwest, great example. Southwest did not go down. Why?
They're running on Windows 3.1. God help them.
Yes, I know. They're running on Windows 3.1, which is highly secure because it can't connect to anything, right? You can't even put a USB stick in a machine running Windows 3.1 because it doesn't recognize it. I mean, this is pretty funny, but at the same time, resilient.
In its own way,
to this one thing. So there's always trade-offs, I guess is what I'm trying to say. There's no easy answer to this except to be prepared.
Yeah, be prepared. And one thing I think we'll see, hopefully, as an outcome of this is a call to the vendor community, as large enterprises, for more resiliency in the system. So having the ability to manage your deployments and be able to roll them back or to be able to recover in a more natural way. It's going to have a call to all vendors to start thinking about how do they test their systems for these kind of resiliency. So there can be some good that, silver linings that come out of this.
There better be. There better be, right? For our industry as a whole, there better be something good comes
out. But the reality you mentioned, and it goes back to, there have been several examples over the last number of years of this idea that we as a society have become completely digitally dependent. All aspects of our lives rely on technologies. And I think this is another example of waking up the public to the fact that everything runs on technology. I mentioned this in I think one of our prior podcasts when when people were looking at the Capital Pipeline ransomware attack.
Oh yeah.
And the JBS one, which I thought was the most interesting, the meat packing in Australia. Yes, ransomware happened, but two things that we learned from that event. One is that everyone is a target. You can't say, well, I'm not in an important industry. I'm
a meatpacking plant. Who cares?
Right. Yeah, you can't get any less sexy than that, and yet they were attacked by ransomware. The flip side is that even the most mundane of things are digitally dependent. You don't think of meatpacking as being a digital enterprise, but yet we saw ransomware took down the line. And so this attack again, you're looking at the cross industry, airlines, hospitals, government agencies, and everyone in between. We as a society are very reliant on these technologies. And until we as a society demand better resiliency of ourselves and of the products we're deploying, we're going to continue to, every couple of years, we're going to have another one of these kind of things because there are, pick on CrowdStrike. That's one critical part of our infrastructure.
Right.
There's so many more products and technologies we take in. Many of them we know, Windows and others. Many of them we don't. They're little third-party apps that are buried in the bottom. But the Log4j, if you will, that's
Log4j is a great example. Yeah.
Into everyone else's software, are the kind of things that we have to be better at understanding the resiliency. And even if I can't fix every problem, I mean, let's face it, Southwest had Windows 3.1. That means they haven't done a whole lot on that system in years. But having processes in place to recover when something goes wrong, because it will, it's not an if, it's a when, is something that every organization can look at and figure out what's the right set of approaches and practices to get back online as quickly as possible.
This is where we have to move to, and hopefully we learned from this incident over the weekend. And hopefully the recovery is done. I think we're pretty close. I think the airlines are back up and hospitals and banks are back up to where they need to be. We're pretty close. Hopefully we as an industry learn from this. And I think it'll be good overall. So Steve, thank you. It's been, I love talking to you because we get good insight. So thanks again for coming on the show.
Yeah, thank you, Darren, and good to be here for number 12 and looking forward to the next one, number 13.
That's right. Oh, or do we skip 13?
No,
I don't know. We'll go plow right through.
Scary episode. We'll do a scary episode.
We'll do a scary episode.
Thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast, Give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about Embracing Digital Transformation at embracingdigital.org. Until next time, go out and embrace the digital revolution.